We sit on Earth small and insignificant, yet we convince ourselves that we understand the vastness of the cosmos simply because we can observe parts of space with our telescopes. Our computers crunch the data and calculate what's likely happening out there physically and chemically. We've pieced together stories about star formation, the movements of celestial bodies, and the origin of the universe, and we call it science. But when a space probe ventures into uncharted territories and sends back data suggesting something monumental, many scientists dismiss it. They shy away from considering the possibility of a new intelligent force in the dark vastness of space. Voyager 1 and 2 are among the most successful space exploration vehicles ever created, traveling unimaginable distances and being the first human-made objects to explore the outer boundaries of the solar system. In 2012, more than 30 years after its launch, Voyager 1 crossed a significant threshold, the boundary where the sun's influence fades and the mysterious interstellar medium begins. For the first time, a human spacecraft touched the infinite darkness of space, where emptiness and silence dominate 95% of the known cosmos. Few could have predicted that Voyager 1 and 2 would witness this historic moment, but what lies beyond the heliosphere, the space surrounding Earth and our neighboring planets, is quite different from the vast emptiness between stars. We often say rockets fly into space, but beyond Earth's orbit, the space we observe through telescopes like Hubble and James Webb isn't the same as the space extending beyond the Kuiper belt. Until billions of kilometers away from the sun, solar radiation and magnetic forces influence space. Only at a far greater distance does the true void, the interstellar medium, begin. For a long time it was unclear when exactly Voyager would reach this point. While researchers had expectations, they lacked hard data. Voyager's measurements surprised them. Where they expected a sharp decrease in particle density, they instead recorded an increase in magnetic forces still linked to the sun. They concluded that there's a sort of stagnation zone where solar forces clash with the interstellar medium, forming a thick buffer, something they hadn't predicted. In 2015, things took a turn. Voyager 1's data showed something so unusual that it confused the mission scientists. Though NASA reassured everyone that this was expected, Voyager's advanced age began to suggest something bigger was at play. The probe sent data that seemed incomprehensible, leading some scientists to speculate that Voyager 1 might have encountered a region where conventional notions of space and time didn't apply. What if it had stumbled upon an unknown force? Not long after this confusion about its position in space, Voyager 1 detected a faint plasma current where there should have been nothing. A thin line of current stretched through the supposed void, puzzling scientists. Official explanations were quick to follow, attributing this to a small amount of superthermal electrons. Yet others remained unconvinced. They believed this strange data pointed to something far more mysterious. Some even speculated about the existence of plasma waves in areas where there should be none, a phenomenon hinting at an undiscovered force within the interstellar medium. Despite NASA's insistence on conventional explanations, some researchers urged caution. They warned against dismissing the possibility of a new force or phenomenon. If we want to explore space between the stars, they argued, we must be open to encountering the unknown. However, mainstream scientific circles and NASA seemed hesitant to embrace such unconventional ideas. Imagine arriving in a new country and instead of embracing the adventure, you only compare it to what you've read in travel guides. This is what some researchers believe is happening with Voyager's discoveries. In a report on the status of Voyager 1, NASA detailed how engineers sifted through decades-old blueprints to resolve the probe's recent issues. They managed to fix a problem where corrupt data was being transmitted by using an onboard computer that hadn't been in service for years. The quick thinking and ingenuity of the Voyager team brought everything back to normal, allowing the spacecraft to continue its journey. However, with both Voyager probes' power levels steadily decreasing, it's expected they will only last until 2025, after which they'll drift into the cosmos beyond our ability to communicate with them. As of now, Voyager 1 is about 23.3 billion kilometers from Earth, and data still trickles back at a mere 160 bits per second, enough to capture essential measurements from the interstellar medium. Although Voyager 1 has traveled nearly 10 years beyond the heliosphere, it remains within our solar system due to the distant Oort cloud of comets and asteroids bound to the Sun by a force still not fully understood. It will take Voyager another 300 years to reach this cloud. Yet in 2023 something unexpected occurred again. Voyager 1 sent back a cryptic combination of ones and zeros, baffling scientists. The probe had already sent strange data twice before when it crossed into interstellar space, reporting a mysterious plasma stream that shouldn't have been there. Inside the heliosphere, we find roughly 100 particles per cubic centimeter, but outside scientists expected to find only one particle. Yet Voyager 1 detected a higher particle density than predicted and on one remarkable occasion observed a full stream of plasma in the interstellar medium where nothing should exist. While some suggested this plasma was a measurement error, others thought it might indicate something profound in the void of space. One theory posited that a stellar flare had somehow traveled through the vacuum, a highly unusual occurrence. Solar flares from our own sun typically only reach the edge of the heliosphere some 15 billion kilometers away and don't extend into interstellar space. The presence of a plasma stream from a distant star would challenge our understanding of the interstellar medium. Voyager's instruments, which have provided invaluable data for over 45 years, faced another issue in 2021 when the probe transmitted garbled data. Though NASA corrected the problem, the occurrence hinted at potential challenges ahead as the probe drifts farther from home. NASA's legendary space exploration vehicle continues to surprise us, pushing the boundaries of what we know and revealing that there is still much to learn. As both Voyager probes fly deeper into space, they may be uncovering new phenomena that demand we reconsider some of our most fundamental scientific assumptions. While the power of these probes will inevitably run out, their journey continues, and their legacy as pioneers in space exploration remains secure. Their greatest discovery might still be waiting in the silent, dark expanse of the cosmos. The NASA team accomplished what seemed impossible. Communication had been re-established with one of the most distant man-made objects in the universe. This meant Voyager 2 successfully overcame a crisis in 2022. After over 45 years, its sister probe Voyager 1 encountered its own challenge when telemetry data became incorrect, causing concerns that the probe had lost its orientation in space. However, NASA's engineers quickly took control. After weeks of troubleshooting, they identified a fault in the onboard computer, and with an instruction sent over 20 billion kilometers, the probe switched systems and a response finally came back. How much longer these space veterans will continue sending data is unclear, but scientists hope to maintain contact with both probes until around 2030, after which they will drift into the depths of space as power dwindles and communication is lost. In 2018, Voyager 2 approached the edge of the solar system, marking the magical threshold of the heliosphere, an area scientists had meticulously planned for. However, the data it sent back defied expectations, just like Voyager 1 did in 2012. Contrary to theories, the heliosphere didn't end smoothly, but was more like a solid wall. This discovery highlighted how little we actually know about the universe, proving once again that until we physically explored an area, our models and predictions remain uncertain. The boundary of our solar system is a complex interaction between the solar wind and the interstellar medium. Voyager 2 found that there were far more particles in interstellar space than previously thought, causing scientists to reassess their theories. The heliosphere itself acts like a large bubble formed by the constant solar wind from the Sun, with a clear distinction in density and temperature between it and interstellar space. At its outer edge lies the heliopause, which extends between 10 and 20 billion kilometers from the Sun. As the entire solar system travels through the galaxy, the bubble moves with it at a speed of 828,000 kilometers per hour. Launched in 1977, the timing was perfect for the Voyager mission due to a rare alignment of planets that occurs every 176 years. This alignment allowed the probes to visit Jupiter, Saturn, Uranus, and Neptune within a shorter time frame than usual. The two almost identical probes, Voyager 1 and Voyager 2, were sent on their journeys in August and September of 1977 respectively. Both probes used gravity assists to travel through the solar system, delivering groundbreaking data about the planets they passed. Voyager 2 revealed the stunning blue hues of Uranus and Neptune, discovered Uranus rings, observed storms on Neptune, and identified new moons around both planets. Voyager 2 will continue its journey through the darkness of space for another 40,000 years before it approaches the star Ross 248. Although it's unlikely to be captured by the star due to its small size, the probe will drift through the interstellar medium for eons, potentially still intact or disintegrating over time. In the event that an extraterrestrial civilization discovers Voyager 2, it carries a golden record with sounds, images, and messages from Earth designed to introduce our species to any who might find it. Voyager 1, which is currently almost 6,000 times the distance between the Earth and the Moon, has also made remarkable discoveries. It was the first probe to reach Jupiter in 1979, capturing detailed images of its atmospheric patterns, including the Great Red Spot, and observing the volcanic activity on Io and the subsurface oceans on Europa. It then passed by Saturn, mapping its rings and photographing Titan, Saturn's largest moon. As Voyager 1 ventured out of the solar system and approached the heliopause, it started to measure the cosmic rays and plasma waves that are thought to populate interstellar space. With both probes still operational, there is no telling what new discoveries might await them, and scientists eagerly anticipate the treasure trove of data they will send back as they continue their historic journeys through the unknown. Both Voyager spacecraft are equipped with an array of scientific instruments designed to measure the environment surrounding them and collect data about cosmic phenomena. Their advanced instruments include magnetometers, cosmic ray detectors, and plasma wave antennas. Scientists expect that as the probes travel deeper into space, they will continue to uncover new phenomena challenging our understanding of the universe. Some researchers argue that it's essential to remain open-minded about their findings, recognizing that they could reveal unexpected truths about the nature of the cosmos. The scientific community has a rich history of paradigm shifts, often sparked by new discoveries that challenge established beliefs. As Voyager 1 and 2 venture farther into the void, they serve as a reminder that space is still an uncharted frontier full of surprises waiting to be unveiled. We must be ready to embrace the unknown and explore the mysteries that lie beyond our comprehension. In this vast expanse of space, the line between science and the unimaginable blurs, urging us to ask questions and seek answers. The true nature of the cosmos may remain elusive, but with every new measurement from these intrepid probes, we come one step closer to unlocking the secrets of our universe.